NFPA 13, specifically Section 10.14, explicitly states that flow switches shall not be installed in fire protection systems. This prohibition is a critical aspect of fire safety regulations and is designed to ensure the reliability and integrity of fire protection systems. To understand the reasoning behind this regulation, it is important to delve into the fundamental principles governing fire protection system design and operation. Fire protection systems, particularly sprinkler systems, are engineered to activate automatically upon the detection of fire. The activation is typically triggered by heat-sensitive elements such as fusible links or glass bulbs within the sprinkler heads. When these elements are exposed to a predetermined temperature, they break or melt, releasing the water pressure and initiating the sprinkler discharge. The design and operation of these systems are intentionally kept simple and direct to minimize the potential for failure during a fire emergency. The introduction of flow switches into the fire protection piping introduces a potential point of failure. Flow switches are electromechanical devices that detect the flow of liquid within a pipe. They typically consist of a paddle or vane that is deflected by the flow, which in turn actuates a switch. This switch can then be used to trigger an alarm, activate other equipment, or perform other control functions. However, the inclusion of these devices introduces complexities to the system. Firstly, flow switches are susceptible to mechanical failure. The moving parts within the switch can become worn, corroded, or obstructed, preventing the switch from functioning properly. This could lead to a failure to detect a fire, or a delay in the activation of the fire protection system. Secondly, flow switches require electrical power to operate. A power failure could render the flow switch inoperable, again compromising the system's ability to detect a fire. Thirdly, the wiring and connections associated with flow switches are also potential points of failure. Loose connections, damaged wiring, or electrical faults could all prevent the switch from functioning as intended. Moreover, the presence of electrical components within the fire protection system introduces a potential ignition source. While fire protection systems are designed to suppress fires, the introduction of electrical devices increases the risk of an electrical fire. NFPA 13 Section 10.51 further reinforces this principle by stating that fire protection system piping shall not be used to trip a device or activate a system not specifically approved for fire protection service. This section aims to prevent the use of fire protection systems for non-fire related purposes, which could compromise their primary function. For example, using the fire protection system to control the operation of a building's HVAC system or to activate a process control system could inadvertently disable or interfere with the fire protection system's ability to respond to a fire. The intent of these regulations is to maintain the simplicity, reliability, and integrity of fire protection systems. By prohibiting the installation of flow switches and restricting the use of fire protection piping for non-fire related purposes, NFPA 13 minimizes the potential for failure and ensures that these systems are always ready to respond to a fire emergency. Now, let's consider alternative methods for obtaining feedback on the flow of water in sprinkler systems. If flow indication is required for monitoring purposes, there are several options that can be implemented without violating NFPA 13. One option is to install flow sensors in a separate, dedicated piping system that is not connected to the fire protection system. This separate system can be designed to monitor the flow of water in the fire water lines and provide feedback to a control system or monitoring station. However, it is crucial to ensure that this separate system does not interfere with the operation of the fire protection system in any way. Another option is to use pressure sensors to infer the flow of water in the sprinkler system. Pressure sensors can be installed at various points in the piping to monitor the water pressure. By analyzing the pressure readings, it is possible to determine whether water is flowing through the system and to estimate the flow rate. However, this method is less direct than using flow switches and may not be suitable for all applications. A third option is to use ultrasonic flow meters, which are non-invasive devices that can measure the flow of liquid without coming into direct contact with the fluid. These meters can be clamped onto the outside of the pipe and use ultrasonic waves to determine the flow rate. Ultrasonic flow meters are generally more expensive than flow switches, but they offer the advantage of being non-intrusive and not requiring any modifications to the existing piping. When selecting an alternative method for flow indication, it is important to consider the specific requirements of the application, the accuracy required, and the budget available. It is also crucial to consult with a qualified fire protection engineer to ensure that the selected method complies with all applicable codes and regulations. In addition to the technical considerations, it is also important to consider the administrative aspects of fire protection system design and installation. All fire protection systems must be designed, installed, and maintained in accordance with NFPA 13 and other applicable codes and regulations. The design and installation must be performed by qualified and licensed professionals, and the system must be inspected and tested regularly to ensure that it is functioning properly. Any modifications or additions to the fire protection system must be approved by the authority having jurisdiction, which is typically the local fire marshal or building official. Failure to comply with these requirements can result in fines, penalties, and even criminal charges. In summary, NFPA 13 Section 10.14 prohibits the installation of flow switches in fire protection systems, and Section 10.51 restricts the use of fire protection piping for non-fire related purposes. These regulations are designed to ensure the reliability and integrity of fire protection systems and to minimize the potential for failure during a fire emergency. If flow indication is required for monitoring purposes, there are several alternative methods that can be implemented without violating NFPA 13, but it is crucial to consult with a qualified fire protection engineer to ensure that the selected method complies with all applicable codes and regulations. Remember that safety is paramount when dealing with fire protection systems, and it is always best to err on the side of caution. By following the codes and regulations and consulting with qualified professionals, it is possible to design and install fire protection systems that will protect lives and property in the event of a fire. Furthermore, it is also vital to remember that the interpretation and application of codes like NFPA 13 can vary depending on the specific jurisdiction and the authority having jurisdiction. Therefore, it is always recommended to consult with the local fire marshal or building official to obtain clarification on any specific requirements or interpretations. They can provide guidance on the specific codes and regulations that apply to the particular project and ensure that the fire protection system is designed and installed in accordance with those requirements. In addition to the specific sections of NFPA 13 mentioned earlier, there are other sections that are relevant to the design and installation of fire protection systems. These include sections on sprinkler head selection, piping design, water supply requirements, and alarm and detection systems. It is important to be familiar with all of these sections to ensure that the fire protection system is designed and installed in accordance with the code. Another important aspect of fire protection system design is the selection of appropriate materials. All materials used in the fire protection system must be approved for fire protection service and must be compatible with the water supply. The piping, fittings, and sprinkler heads must be made of materials that are resistant to corrosion and degradation. The selection of appropriate materials is crucial to ensure the long-term reliability and performance of the fire protection system. Regular inspection and testing are also essential to maintain the integrity of fire protection systems. NFPA 25, the standard for the inspection, testing, and maintenance of water-based fire protection systems, provides detailed requirements for the inspection, testing, and maintenance of fire protection systems. These requirements include regular visual inspections of the sprinkler heads, piping, and other components, as well as periodic testing of the water flow and pressure. Any deficiencies identified during the inspection or testing must be corrected promptly to ensure that the fire protection system is ready to respond to a fire emergency. In addition to the technical requirements, there are also administrative requirements associated with fire protection system design and installation. These include obtaining the necessary permits and approvals from the authority having jurisdiction, as well as providing documentation of the system design, installation, and testing. It is important to comply with all of these administrative requirements to avoid delays and penalties. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Fire protection system design and installation is a complex and specialized field, and it is essential to consult with qualified and licensed professionals to ensure that the fire protection system is designed and installed in accordance with all applicable codes and regulations. Remember, fire protection systems are designed to save lives and protect property, and it is crucial to take them seriously. By following the codes and regulations and consulting with qualified professionals, it is possible to design and install fire protection systems that will provide reliable and effective protection in the event of a fire. It's worth noting that the technology related to flow monitoring is continually evolving. While direct inline flow switches within the fire protection system are restricted, advancements in wireless sensing and data analytics are offering new possibilities for monitoring fire water systems remotely and non-intrusively. These technologies, when approved and implemented in accordance with relevant standards, can provide valuable insights into system performance without compromising the integrity of the fire suppression infrastructure. The considerations surrounding flow switches and fire protection systems highlight the importance of adhering to established codes and standards, while also staying informed about emerging technologies that can enhance safety and efficiency. The core principle remains that the primary function of the fire protection system should not be compromised, and any monitoring or control functionality should be implemented in a way that does not introduce potential failure points or risks. Therefore, a comprehensive approach that combines code compliance, engineering expertise, and awareness of technological advancements is essential for ensuring the reliable operation of fire protection systems. Furthermore, when considering alternative methods for flow indication, it's crucial to evaluate their suitability for the specific environment and application. Chemical plants, for instance, often present challenging conditions due to the presence of corrosive chemicals, extreme temperatures, and potentially explosive atmospheres. Therefore, any flow sensors or monitoring devices used in such environments must be designed and certified to withstand these conditions and prevent any ignition hazards. The selection of appropriate materials, the use of explosion-proof enclosures, and the implementation of intrinsically safe circuits are all critical considerations for ensuring the safety and reliability of flow monitoring systems in chemical plants. Also, proper training for personnel who will be involved in the installation, maintenance, and operation of fire protection and flow monitoring systems is extremely important. These individuals should have a thorough understanding of the relevant codes and standards, as well as the specific requirements of the systems they are working with. Regular training and refresher courses can help to ensure that personnel are competent and knowledgeable, which can reduce the risk of errors and accidents. The design and maintenance of fire protection systems are not static processes. As built-in codes evolve and new technologies emerge, it's crucial to stay updated on the latest changes and advancements. Subscribing to industry publications, attending conferences and workshops, and participating in professional organizations are all effective ways to stay informed and connected. Furthermore, engaging in ongoing professional development can help to enhance knowledge and skills, which can lead to improved fire protection system design and maintenance practices. Fire protection is a multidisciplinary field that requires collaboration between engineers, architects, contractors, and building owners. Effective communication and coordination among these stakeholders are essential for ensuring that fire protection systems are designed, installed, and maintained in accordance with all applicable requirements. Regular meetings, clear documentation, and open channels of communication can help to prevent misunderstandings and ensure that everyone is working towards the same goals. The ultimate goal of fire protection is to save lives and protect property. By understanding and adhering to the codes and standards, consulting with qualified professionals, and staying informed about the latest advancements, it is possible to design, install, and maintain fire protection systems that will provide reliable and effective protection in the event of a fire. Remember that fire protection is not just a technical issue, but also a moral and ethical responsibility.